Okay, this is the first time I have done this style, so if this is the if this is what you're hearing, then that means I successfully did it on my first try. So let's hope for that. Let's review real quick on this problem that we got halfway through on Wednesday last week, and then we're gonna finish it out. So number 21 from page 255. I should have pulled that up in my textbook in advance, but part A was asking us to find the rate of change, if I remember correctly, the rate of change between the baseball and first base. What's the rate of change of the distance between those two? And at the moment that the ball is halfway to third base. Okay, let's just do a quick review. We knew that uh, A was 90 because that was the side of the distance from home plate to first base, and B was 45, halfway to third base. We could find the distance D at the moment we cared about by using the Pythagorean theorem. 90 squared plus 45 squared equals D squared. And so we could isolate D, and it was the square root of 10,125. And then dA dt, there's no rate of change for dA dt in part A because the distance is not changing between home base and first base. And then dB dt is 100 feet per second because the ball is traveling 100 feet per second. dD dt is what we were trying to find, the rate of change of the distance with respect to time. And so we set up our equation, we drew a picture, we differentiated. I hope this is still all in your notes and that you're able to review this. And we found ultimately that the distance between the baseball and first base was changing at 44.72 feet per second at the moment where the baseball was 45 feet away from home base. Okay, Part B asks us, open up your textbook if you're not there to page 255. Part B asks, at what rate is the distance between the ball and the player changing when the ball is halfway to third base? So here's the work for B. Let's add to our picture. Part B says the distance between the ball and the player. The player is running along the line between first base and home. So the player is going here along the way at 25 feet per second. So we want to find this new distance D. I'm just going to use D again because we already have D built into our equation. So I'm just going to use D again. You could totally name it something else if you want. Excuse me. The distance here is what we are trying to find the rate of change in this distance. Okay. Come on. Here we go. We are going to take that information and recall our derivative formula for this scenario. 2a dA dt plus 2b dB dt equals 2d dd dt. Okie dokie. Now we know, let me see if I can get this straight because my notes are labeled differently than our picture. So we know dB dt, that is 100 feet per second. We also know B is going to be 45. We know that we know that dA dt is 25 feet per second. And we don't know A at this point, but could we find A? This is where we want to think about similar triangles. Okay, this is also something that should be in your notes. If not, let's see. We talked about it all the way up here. We talked about similar triangles. They are proportional. The sides and rates of change, I should say, are proportional to each other. Specifically, this one right here is going to help us find the value of A. So let's go back down to our problem. Okay, I know that A over A prime is going to be B over B prime proportionally. So I know that B is 45. So I can put in 45 for B, and B prime is 100 feet per second. So that's going to equal A, which we're trying to find right now, over A prime, which was 25 feet per second. I only have one variable in this equation, so I could solve for A. So when we do that, we do get A equals 11.25. There are definitely other ways that you can find this value. This is my favorite way to do it because it's pretty cut and dry. But if you had another creative way, actually, let me know because I would like to hear about that. So we know that A is 11.25. Okay, so we've listed out some of the things we know, and we know dB dt, we know B, we know dA dt, we know A. We are trying to find d dt. Let's see if we can find d. Well, we can find d. D is easy to find because we have the Pythagorean theorem. So let's review that. If A is 11.25 and B, recall, is 45, then we can just take 11.25 squared plus 45 squared equals d squared. And when we work this out, you should get d is the square root of 2,151 and 5,625 10,000ths. Okay, there you go. This would be the exact value of d. So we're going to leave it as an exact value. Calculus, we like exact values, and we don't really like estimates as much. Let's plug in all the information we know. So I'm going to be using this formula here, where I'm erasing the check marks. We're using this formula to plug in everything we know. So come back down here. 2 times A, which is 11.25, times the rate of change, dA dt, which is 25, plus 2 times B, which is 45, times dB dt, which we know is 100, and that is equal to 2 times d. Well, we just found d. It's right there even on the screen. That is the square root of 2,151, 5,625. Finish my radical. And d dt. Now, I am going to skip all the algebra. Please just trust me. Please do it yourself. d dt is going to be equal to, once you simplify all of these terms and isolate d dt, you will get 103.078 feet per second. Okay. If I did my math wrong, also please let me know. But that is what I wrote down for this rate. But I'm pretty sure that would be correct. And it makes sense contextually. But if I maybe got a few decimal points wrong, please let me know. Okay, there you go. So that was part B for that problem that we didn't finish. Okay, so let's move on. So I have a new problem for us. Let's see, I've called it example 8. Here she is. Go ahead and pause the video if you need to copy this down. In fact, please copy it down. Okay, find the rate of change in the angle of elevation of the camera shown in the figure at 10 seconds after lift off, given position equation h equals 50t squared. Also, there is some information in the diagram here that's not stated in the sentence. This 2,000 feet distance here between the camera and where the rocket launched off, and we also have the height labeled, but it doesn't really give us any other information than that. Okay. The first question that we're going to want to ask here is, what do I know? We already have the picture, so what do I know already? Or what can I find? Pause the video, give this problem a shot, see what you can find, see how far you can get, and then come back when you've tried. Okay, hopefully you had some time to work on that. Let's find what we know. We know that h is equal to 50t squared. I'm actually going to change my pen to orange here, so one sec. There we go. H is 50t squared. We are interested in the position when time is 10 seconds. So when t is 10, we could find the height. Well, that'd be really easy if we just plug in 10 for t, and so we would have 50 times 10 squared, which is 5,000 feet. So h at the moment we care about is 5,000. We also know dh dt, that is given to us. That is actually 100t. Mr. Hadding, how on earth did you get that? Well, notice that if I take the derivative of this formula here, I would get the derivative of h is dh dt, and then the derivative of this is 50t squared. So, and notice that this t is time. So really, actually, I have dt dt right now because remember, implicit differentiation, we are differentiating here for related rates with respect to time. But because this is the time variable, this dt dt is actually just going to cancel out, kind of like our dx dx situation when we used to do implicit differentiation just by itself. So there's your dH dt. It is equal to 100t. Now, really, ultimately here, we are trying to find d theta dt because the angle of elevation is what is changing, and we want to find the rate of change in that angle of elevation. So we are ultimately trying to find d theta dt, specifically when t is equal to 10 and h is equal to 5,000. At this exact moment, we want to know what d theta dt is. Okay. Well, we've written what we know. We have a picture. Step 3, let's relate the variables. Okay, how could we relate the two pieces of information we know given this picture? If you haven't thought about this already, pause and give it a think. We want to relate h and theta if we can. H and theta could relate actually by a trig equation or a trig function. Which trig function relates the two sides that are labeled here? Hopefully you thought of tangent right away, noticing that we have the opposite side looking away from the camera and the adjacent side to the camera. So we know that, I'm going to clear this back out just for this clutter, but we know that the relationship of h and 2000 can be related by tangent. So that actually is a way to relate all of our variables here. Tangent theta is going to be h over 2000, the opposite over adjacent sides. Now that we have our equation, let's differentiate and see if we can find d theta dt. The derivative of tangent with respect to time will be secant squared theta d theta dt. That was a bad theta. D theta dt. Remember, we're differentiating with respect to time, and so we need that chain rule. We cannot forget the chain rule for d theta dt. And then h over 2000. Now, save yourself the work. Don't do quotient rule here. This is really just the power rule. If I take that 1 over 2000 off to the side, I really just have an h. So I really am just going to have 1 over 2000 dh dt. Okay. If that step did not make sense, please rewatch or otherwise make sure that you understand that step. Okay, now I have d theta dt here in my expression, but let's get it by itself so that we can solve and find its value. Okay, if you recall that secant of x equals 1 over cosine x, then it is easy to see that I could easily multiply this side by cosine squared and be able to move the secant squared to the other side, in effect. D theta dt would be all by itself if it's equal to cosine squared theta over 2000. Let's see. Okay, I'm just going to leave the 1 over 2000, and then I'll write the next step, dh dt. Okay, then we do know dH dt. Remember dH dt, we found an expression for that. So d theta dt equal to cosine squared theta over, well, I'll just do it like this. 100t over 2000. That's cleaner. Okay, this is pretty clean. Uh, we are at the situation where I do know t. Remember, we know that t is 10, so I do know that. The problem is I don't know theta at this moment. So what am I supposed to do with this cosine theta? What in the world is going to be cosine theta? Well, let's go back and remember that cosine is a ratio of sides in this triangle. Cosine from SOHCAHTOA is your, hopefully you said it, it is your adjacent over hypotenuse. There we are. So we know that it's going to be this adjacent side and the hypotenuse side. Well, I don't have anything written for the hypotenuse, but hopefully you see that you could easily find it. It would be um, the square root of h squared plus 2000 squared. Okay, so that means that cosine of theta is going to be 2000 over square root of h squared plus 2000 squared. Okay, so we're going to save that. We are going to come down to here and recalling that cosine theta is 2000 over the square root of h squared plus 2000 squared. Now you might be like, wow, that is not helpful, Mr. Hadding. You're just going to make it messier. Yes, it is going to be messier, but it is okay because we, if you look right here in this bracketed area, we know what h is. And the rest of these are just numbers. We can calculate numbers, but we actually know what h is at this moment that we care about. Remember that h was 5,000. So by substituting this value in here, we actually are making it so that we can solve this, even though it might get a little messier for only a moment. So if I substitute this, we're going to have d theta dt is now equal to 2000 over the square root of h squared plus 2000 squared because cosine squared is here, okay? And then that is going to multiply by 100t over 2000. Okay, it looks messy, but actually a lot of these things cancel. I've got two 2000s up here, but I have one 2000 right here, so that actually is going to cancel. So ultimately, I'm going to get d theta dt will be equal to 2000. And also, I know what t and h are equal to, so I can substitute those values at this point. So if I combine my fractions and substitute my values, I'll have 2000 times 100 times 10 over 5,000 squared plus 2,000 squared. If you aren't sure where any of those values come from, you need to know, so make sure that you figure that out. If that step was confusing, you could always email me and ask me to explain more, but for the sake of time, I hope you understand. Just notice that this is h, 5,000, remember, is h. Okay, so if I simplify the math, you should get 2 over 29, and then we need a labeled. Please do not forget your labels. You will lose points on the AP exam if you do not have your labels. Radians per second is the rate of change label here. Okay. Hopefully that one was helpful because I wanted to show you this because we can find problems like this where we want to know the rate of change that this angle is changing. And so we're always going to try to find that in radians per whatever the time unit is in the situation. And so hopefully this is a helpful example for you if you see a similar problem on the AP exam. Okay, the last problem I want to do with this video is one that you have in your flipped math packet. And I've put the digital PDF version of it right here for us so I can draw right on it. But please get this out of your packet now if you don't already have it in front of you. I'll pause the video so that you can go get it. Okay, this should be on the back page of your Flip Math packet. And Go ahead also and take a moment to read the entirety of the problem all the way through C. By the way, we are ignoring this 14 problem for now. Feel free to do that for fun, but we are focusing on the free response. Okay, hopefully you had some time to read that. I'm going to go through this problem because I think it's a really helpful example of not only what a free response question will look like and feel like, it will also give me an opportunity to explain the parts and pieces of how a free response question will be scored on the AP exam. And finally, this is about the most challenging that a related rates problem can really get. Other than like our oil slick problem, this is also a fairly difficult one, but it's actually not so bad if you get just a couple key player information pieces of information. So all of that said, I hope this is a really helpful example for you in the long run. I'm gonna try and zoom in as much as I can. I'm not gonna read it because you should have just read it. So part A, we need to do part A. All right, so find the volume V in the container when H equals 5 centimeters, indicate units of measure. They even give you a reminder to include your unit label, so don't forget it. Okay, this part A requires literally no calculus at all because it does not ask you to find the rate of change. It's just asking you to find the volume, okay? They also give us the volume formula right here in the problem. So we don't have to remember that or memorize that for the exam. They will give you the formulas you need. All right, all of that said, we need to find the volume. Okay, volume is equal to 1/3 pi r squared h. Now, it gives us h right here in the problem. So I already know h. That's totally fine. No problem whatsoever. H equals 5, okay? H equals 5. Also, by the way, you will have more room to write these things on the AP exam than what this packet is giving you. So don't feel like you're going to feel the same stuffiness that this problem is going to have space-wise on the AP exam because you'll have like unlimited scratch paper on the AP exam. Okay. If H is 5, how could we think about finding R? Well, I'm going to add to this diagram. I'm going to add this vertical line here. Because this is a right cone, I can add this, and I think it'll be helpful to see that we have a right angle here, and we have a right angle here. And so we have similar triangles in this cone right here. If we know that, let's see, I can also label this radius. That can be 5 centimeters because the diameter here is 10 centimeters. Okay, so adding that information in, we could try to find a relationship between R and H that would help us to find what the radius will be at the moment that H is 5 centimeters. The height is 5 centimeters. So using similar triangles, we know that R over H is going to equal 5 over 10. Convince yourself that this proportion is true if you are not already convinced. Okay, I'm going to save us again the steps for the sake of time, but you should write out the steps if you need to. But I'm going to go straight to what R equals here. R is going to equal 1/2 H, okay? So we know that R is equal to 1/2 H. Now, at the moment here that we care about, H is 5. So let's actually just plug 5 in and find the exact value of R. If I plug that 5 in for H, then I'm going to have, let me move my pieces around here a little bit so that we have a little bit more room. R is going to equal 5/2 when H is 5. H is 5. Okay, so R is 5/2. Well, now that we have R, and now that we have H, we can plug in to find the volume pretty easily. Volume equals 1/3 pi 5/2 squared. H is 5. If you simplify the arithmetic, which I'm not going to show you. Again, you'll just either trust me or do it yourself on your own calculator. Oops. Is going to be 125 over 12. And then do not forget your label. Volume is centimeters cubed. Okay. You would score 1 point for the boxed solution. You don't have to box things on the AP exam. I'm just saying that this box would score you a point. Also, you will get a point for showing that R equals 1/2 H. You need to show this to show where it is that you got that value for R from. And so you need to show that. That will give you a point. Okay, let's move on to B. We haven't done any calculus yet, so let's move on to B. Oh, now we're finding the rate of change. The rate of change of the volume of water in the container with respect to time when H is 5 centimeters indicate your units of measure. Again, they so helpfully remind you to include your units at the end. Okay, let me help you interpret this just to get us started. We want to find the rate of change. We want to find the rate of change of specifically the volume of water, the rate of change of the volume with respect to time. We want to find the rate of change of the volume with respect to time when specifically H equals 5. Okay, this is what we want to find. So this is the math notation of exactly what it is that we want to find. Not only is this super helpful right from the start to go, this is exactly my goal, but also this is the kind of notation that you would need to get full points on your notation and answer and everything going on your free response question if you had one similar to this. Okay, so now that we know our goal, let's see what it is that we know. Remember, related rates problems, we need to list out what we know and an equation to relate the variables. Now, they've already given us a picture and they've already given us an equation to relate the variables. There's your picture, there's your equation. So mostly we just need to write out what we know. All right, well, we know that the H is going to be 5. We know, therefore, that the radius will be 5/2. We know also dH dt. That was given in the problem prompt above, that it's -3/10 centimeters per hour. That is your dH dt. So because we know those things, we actually have a pretty strong start on being able to solve this. Now, there are two ways to solve part B here. I'm going to move this out of the way because I want more space to be able to show you, but and then I'm going to make it a little smaller. Okay, dV dt at 5 is over there now. Okay, we know that the volume of a cone is 1/3 pi r squared h. The issue is that I have a lot of variables there on the right side that when I try to take the derivative of that, it might get a little bit messy. Again, there are two ways to do this, and I'm going to try to show you both and keep this under a reasonable amount of time. But we could substitute the R variable for H variables, because if you look right here, we have an equation that relates R and H. So R equals 1/2 H. I can use that to just substitute in 1/2 H everywhere that I see an R. Okay, so in my volume equation, I will have, I'm going to write it here, volume equals 1/3 pi. And then this is where I'm going to substitute R so that I have only H's, which just helps simplify it a little bit. If you do this arithmetic, you're going to get 1/12 pi H cubed. Okay, now I have a formula that has only an H on the right side. So when I take the derivative and I get that dH dt into the mix, then I actually know all those values, so it'll be really easy. If I take the derivative with respect to time, I'm going to get dv dt equals 1/4 pi h squared dH dt. Can't forget dH dt because again, we're differentiating with respect to time. Okay, so you have 1/4 pi h squared. If you're not sure how to get that 1/4, work it out yourself. We're really just doing the power rule there, bringing that 3 down, dropping that exponent by 1. Okay, dH dt. All right, we know h, we know dH dt. So I'm going to come right back up here. I'm going to erase my question mark, and we're going to fill this in. dH, dV dt at the point where h is 5, or at the situation where h is 5, we're going to have 1/4 pi. 25, because remember, h is 5, so h squared is 25. And then dH dt is that -3/10 from the above prompt that they gave us. If you simplify down all of this arithmetic, you are going to get -15/8. And then do not forget your label. Okay, here you go. We've got -15/8 centimeters cubed per hour. You would need to show all of this work to get full points for B. I'll box these as well to show you what you would get points on. The answer is going to give you 1 point, so that's 1 point right there. You would get, let me check the scoring guide real quick. Yep, you would get 2 points for the correct dV/dt equation, and you will get 1 point for having written V as a function of one variable. That is altogether worth 4 points, which is quite a lot. Okay, the other way that you could do this is you could leave the R in there, and that's totally fine. Let me erase this line because we could actually move that line. It's not written in pen, so that's super nice. Okay, the other way to do this is you can leave R into the equation. The tricky part is you have to find dr dt, but we have some clever ways to do this, so let me show you. There is a little bit less work kind of with this way, except it's messier work. So pick your poison. You can solve this problem either way and get full points, and it's totally, totally fine. But whichever one vibes with you more is the one you should go for, because you do not want to make mistakes. If you make one mistake on the chain rule or one mistake on the product rule for a problem like this, you immediately lose the 2 points that you would be getting for that equation because you don't have the correct formula. So just making sure that you know which one is the most comfortable for you and which one makes the most sense is definitely the route to go. Okay, volume equals 1/3 pi r squared h. We can leave that r in there and we can just do the product rule of these variables. So we know how to do the product rule, that's no problem. So dv dt, we can actually just take that straight away without needing to do any substitution work. So dv dt is going to be 1/3 pi. Those are just constants that carry along for the ride. That would mean the derivative of the first is 2r h dr dt. Plus, I'm going to try to keep it on the white of the paper, but I'm probably not going to be able to. Plus r squared dH dt. This is the product rule. If that does not make sense, you should please make sure that you understand where that all came from. Okay, we know dH dt. That is -3/10. We know r. That's 5/2. We found that above. We even know h. And again, r. H is 5 and r is 5/2. What we do need to find out is, what is dr dt? What in the world is dr dt? How could we find that? Well, fortunately, we have a nice little simple equation for r right above. Right here, r equals 1/2 h. Using that, we could find the derivative of r with respect to time. And so we would know, let me just do it in a different color to really highlight. All right, that way it doesn't get messy. If I take this, then I'm going to have dr dt is going to equal 1/2 dH dt. Again, if you're not sure where all of that comes from, please ask me, or otherwise make sure you understand by pausing the video. Okay, so we have dr equals 1/2 dH dt. So I can actually substitute in for dr dt here for 1/2 dH dt, which I know dH dt is -3/10. Okay, all good news. So I have to go find my green pen again. All right, so let's substitute everything in and solve for dV dt. dV dt equals 1/3 pi 2r is 5/2. H is 5. dRdt is 1/2 dHdt. Now, remember, dHdt is negative 3/10. So I'm going to just put in negative, let's see, why is it not erasing? There we go. I'm going to put in negative 3/20ths, just to simplify that a little bit. Make sure that makes sense. And then plus r squared is 5/2 squared. dHdt is negative 3/10. Again, I'm really trying to stay on the paper, but it's not going to work out. Okay. All right. Now we just have to simplify all our numbers. That looks pretty nice and easy. I guess I should add another parentheses here to close all my parentheses. And now we just have to simplify. Throw it all in your calculator. dVdt, shock of shocks, is going to be negative 15/8 centimeters cubed per hour. We already knew that because we solved it on the left side. But I'm showing you there's two ways to do this. You have options. If you pick one strategy, you're going to be okay. You can get there. Just pick the one that you like more. Okay, I think I only have a couple minutes left before this is going to kick me off, so I'm going to try and get through C pretty quick here, but C is a really fun problem. Show the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. What's the constant of proportionality? So let me help you again interpret what we are trying to do here. We want to show something. When we show something, that just means that we need to do the steps. We don't really have to like solve for something. We just need to show the steps. We want to show that the rate of change of the volume of water, with respect to time due to evaporation is directly proportional to the exposed surface area of the water. When we think back to our Algebra 1 or Algebra 2 days to the idea of being directly proportional, we want to think about how K is going to be multiplying some quantity that is directly proportional. That is what we call directly proportional. So we want to find some K. You could use any other variable besides K, but usually in math we use K to show that constant of proportionality. But you, again, are welcome to use any other variable. We ultimately want to show that this K is directly proportional to the exposed surface area of the water. First, we want to think, what are we trying to show? I want to show the rate of change of the volume is directly proportional to the area with some constant of proportionality. So then the question is, what is the area of the exposed surface area? What would be a formula that could represent the exposed surface area? But I want to ultimately show that this K is directly proportional to that area. If you look at the picture, you could think about how, oh look, the exposed surface area is a circle. So the area is going to be the area of a circle for the exposed area. So ultimately, we want to show that dVdt equals K times the area of a circle. We want that pi r squared at the end. Let's see if we can make this happen. Let's recall, let me real quick. Yeah, no, I think we're fine. dVdt, I'm just rewriting our dVdt formula, which is 1/4 pi h squared dH dt. Okay, we know dH dt, so I'm actually going to go ahead and substitute that in right away. And maybe I should not have erased it, but okay, dH dt. I'm going to rewrite this with dH dt plugged in. What is dH dt? It is negative 3/10. Still the same. So when we plug that in, we're going to get negative 3/40ths pi h squared is dV dt. Okay. Mr. Hadding, we want to show pi r squared times k. What in the world? Well, here's the thing. We don't know what k is yet, but once we get to the end, it's going to be really easy to see what k is. But we don't need to worry about that till the end. What we need to worry about is converting this part of our equation to look like pi r squared. So the good news is we already have a really simple relationship between h and r. Look at the red arrow. R equals 1/2 h. I could rearrange that to get h equals something in terms of r. And in that case, we would have h equals 2r. There we go. So I could easily substitute that 2r in for h. So I would have dv dt, and I'm totally going to run off the paper at this point. Hopefully you can fit yours in with a pencil. All right, negative 3/40 pi times 2r squared. You might be able to see where this is going. See if you can finish out the problem on your own, but dv dt is going to equal negative 3/10 pi r squared. Okay, notice that we have pi r squared right there. So that is the area of your circle. So we have already done all of the show work. This is all you need to do to show. But what you do need to do is directly answer the question that they asked, which is, what is the constant of proportionality? The constant of proportionality is negative 3/10. It's kind of amazing that it's actually the exact same as dH/dt. That is a coincidence, so it will not always be that case. Don't rely on that. Okay, and that's all you would need to do to score full points on C. You would need to show this box and this box to get the full points on part C. That's a lot of work, but guys, we just pulled off a really fun and really complicated problem. I hope this is helpful for you. Have a great Tuesday.